Snark Chocolate, a show about ZK products where we break them down with rich flavors and sweet insights. My name is Omer and I'll be the host for this show. Today, we're thrilled to be joined by Dante, CTO and co-founder of EZKL, working on securing machine learning with zero-knowledge proofs. Dante, it's great to have you here.
Yeah, great to be here.
Can we start with a brief introduction? How about you share with us your story, how you came to work on EZKL?
Yeah, for sure. It's kind of a circuitous path, I think, because it's a project that merges lots of different disciplines and interests. So I came to I guess, the cryptography space during the pandemic. I was working with a friend on a decentralized content delivery network at the same time that I was doing my PhD. That company sort of exited at the same time that I completed my PhD, where I was studying neural networks, machine learning, that sort of thing. And I think I was pretty burnt out then, and I was trying to find what to work on next. I had this longstanding interest in privacy-preserving machine learning, so basically methods which allow you to deploy machine learning models and networks in a way that preserves a user or a person interacting with them's privacy. And sort of by happenstance, I was in New York visiting my grandmother. A bunch of the Zero X Park folks were here. I went to a talk they were giving. I met some of the founders, and they introduced me to Jason, who's my co-founder, over email. And then turns out that he was working on this ZK machine learning project with the intent of preserving the user's privacy. And then that sort of kicked off EZKL. For the first 6 months, we were just the two of us working on Discord, cranking out code. And gradually, the library got more and more interest, and it turned into more of a fully fledged project and company.
Take me to the early days. You and Jason, what was it like? What were the challenges? What was the approach that you wanted to take? How is it different from nowadays?
Yeah, for sure. Well, I guess we didn't meet for 6 months, so we were solely communicating over Discord to get this off the ground. I think I was more familiar with, like standard machine learning libraries and programming, more so than ZK. And so that's very much the approach we took when building this. So if you look at the library, it's basically like a standard machine learning library with a lot of cryptography under the hood, but we've re-implemented a lot of the base like machine learning operations like convolution, all this other stuff, um, in a ZK fashion. But in terms of challenges, I mean, I had a job, so I had to do this at night. Um, and this is now my full-time job. But yeah, so
Okay, let me take one step back and jump right in. So, what what is it that you are building actually? What is the product? What kind of pain you aim to solve and how?
yeah, that's a great question. I think so. Initially, the library was a ZK machine learning library. I think the way we've conceptualized it and the way people are using it now has sort of changed. So if you think about, the computations involved in machine learning, it's a bunch of multiplication, it's a bunch of addition, maybe some like nonlinear functions slapped on top. And there's nothing about that which is particular to neural networks or machine learning algorithms. And what we found is that the library is an interesting way to extend the computations that you can do verifiably on a blockchain. And what I mean by that is essentially the library, at a very high level, takes Python code, compiles it into an equivalent ZK circuit, and generates a smart contract that can verify these computations on chain. And so what this allows you to do is to take like a bunch of complicated computations and operations that you might have wanted to do on chain. So for example, say you have a lending protocol on chain and you want to do risk assessment to determine how much value a person can take a loan out on. Well, if you wanted to run that on chain, it would be exceedingly expensive, especially if you're running this computation pretty frequently. What the library allows you to do is to express this as a short snippet of Python code, compile it into a ZK circuit, and then have a verifier on chain that can verify that you ran these computations correctly off chain, but whilst preserving the security and verifiability of the chain.
So when you say library, that's it. Like that's the product. But you do have some solutions around it, right? Some offerings. I've seen, for example, something called Lilith.
Yeah, for sure.
Can you maybe share more about the tools that you are building as part of your ecosystem?
Yeah, for sure. So I guess obviously the library is still the core part, the core thing people interact with. But I think the DevOps and infrastructure to support the deployment of ZK applications is pretty involved. I guess from my background, working on decentralized networking stuff, we also have some expertise in the deployment of like large compute clusters and like orchestration across like many nodes for the creation of proofs. So Lilith is also a proving backend, I guess, which allows someone to simply send us an Onyx model, which is Onyx is just a universal representation of a computational graph or a machine learning model. And then we take it, compile it into a ZK circuit, deploy it on a bunch of our machines, and they get a simple HTTP API to generate proofs with. So within 2 clicks, you can have like a ZK backend deployed and serving proofs for you.
Okay, so something I'm trying to understand is how this, or what's the ideal scenario here, or the kind of like user that you are aiming for. For example, you recently published a work on client-side proving, pushing the envelope on performance on Apple Silicon, right, Metal. So this is kind of like moving stuff to run user side, client side, and you just described that you also have this like DevOps for teams on data centers. So how you resolve these two?
Yeah, I guess so. Ultimately, we have 2 categories of users. I think the pure blockchain applications are, the classic saying is like if you're doing ZK snarks, some people are solely interested in snarks, so they're not interested in the privacy preserving properties of these algorithms. They mostly want a proof of computation, in which case it's totally fine to delegate proof generation to our cluster, right? You still get a verification that a computation was run correctly. And you don't necessarily need like privacy of the inputs that are being fed into a machine learning model or something like that. And I think broadly, like a lot of the DeFi applications that are using us fall into that category. But there's a whole slew of folks that are interested in the privacy preserving properties of ZK snarks. And what they want to do basically is to keep data on a user's device, say, for example, their phone, and they want the user to generate a proof that they ran some computation correctly. So say, for example, an identity check or some facial recognition algorithm that they want to run on someone's phone, get a guarantee that this person is who they say they are, without this person having to send images of themselves or like scans of their passports over the wire.
Okay, so you cater for both, right?
Yeah, that's the idea. If a user comes to us and says, I want this, typically we will build that.
Are there any particular security assumptions that you are making here about the system, the user, or anything like that?
Yeah, I guess in particular, the input data needs to be attested to somehow, you know. I guess like it's very easy in these systems for someone to input arbitrary data, and machine learning models in particular are somewhat vulnerable to tampering of inputs and adversarial attacks. So you're sort of assuming that the data somehow can't be manipulated by the person that is that is generating the proof. So, for example, say in the case where it's deployed on our cluster, a lot of our users use on-chain data as inputs to the models because you can create during the verification process, you can create a guarantee that like the same on-chain values that you were using are the ones that were living on-chain, basically. And I guess conversely, if you're generating proofs client side, uh, you know that you can attest to the fact that like say for example some input image was generated by an iPhone's camera or something. So that's sort of the idea. But it's definitely a tough technical challenge, and I think it's one of the trickier parts of like designing ZK applications is like how do you trace and account for the data that is being fed into a circuit.
Are there any assumptions on the prover itself, some SRS or something like that?
Yeah, for sure. That's another thing. So we sort of have a lightly modified version of Halo 2. So there is an SRS. We use like the one of the public ceremonies that was generated for the SRS. But yeah, there's always an assumption there in terms of security.
Got it, got it. Let's cover briefly some use cases. Starting from those that you've seen so far, anyone of you that you want to highlight?
Yeah, for sure. So I think over the past quarter, we've really tried to double down and focus on DeFi in particular because they have what we found when talking to a lot of these users is they have a bunch of quants internally. B, they have a bunch of like Python code and Jupyter notebooks that they've had laying around for a long time that they've been wanting to implement on chain. And basically, we've given them tools that they see immediate value in. They take their Jupyter notebooks, they convert them into a ZK circuit, and these complicated models that they wanted to run on chain, they can now just like prove and verify directly. So almost immediate value add for them. I think in terms of exciting projects, we're working with Sentiment, which is a lending protocol. Their second version is launching soon. We're going to have some integrations with that. And we're helping them determine like very effective loan to value ratios for their lending protocol and just updating that constantly. If you look at some of the legacy lending protocols like Aave, the process for updating that loan to value is kind of, yeah, it's kind of clunky right now. Like they outsource the modeling to a company like Chaos Labs or Gauntlet, and every like 3 to 4 months, I mean, sometimes it's 12 months, like this value on chain gets updated by way of them like creating a post on the DAO. A lot of people have to vote to adopt this new loan to value. And so it's just not a very efficient way to do lending, basically, because you're not particularly reactive to market conditions.
Okay, what about use cases that you want to see? Stuff that,
Yeah, that's it. That's pretty interesting. So I think I was somewhat bearish on ZK identity, um, partially because I'm not entirely sure. I think partially because I just hadn't seen a very good user experience yet. But recently we started working with this project called Sundial. They're building this ZK KYC uh, project for called OnFlow. Um, I was able to try the app somewhat early, and the onboarding flow is super smooth. Like you basically take your phone, slap it to your passport, reads the data via NFC, and then you can generate proofs from that data almost immediately to authenticate yourself for on-chain applications and other applications without necessarily revealing the full extent of your data or like sending your passport data on the wire, which is super exciting. We're looking at ways to collaborate, potentially to extend some of their identity protocol with like facial recognition stuff and that sort of thing. So I'm super excited about that category now. Which I think it's a testament to like how good they are as like app developers and that sort of stuff because they've created such a smooth onboarding flow.
Very cool. So I want to ask about the evolution of the project over time, starting from performance. So do you have this kind of like, since you've been going on for quite some time now, so do you have some kind of like Moore's law internally? Do you get to see performance improve over time? Is it like at the same pace that you'd say that the industry is moving, or you are accelerating even that pace?
I mean, the industry is moving super fast. I think what's been quite different about our approach is that a lot of, well, the performance has improved drastically since we first started, like I think almost 10,000x um, for the proving of some models. But I think our approach has been somewhat um, contrarian in that like the back end has remained somewhat stable. You know, we've swapped out some of the lookup arguments, all this other stuff, but a lot of the performance improvements have come from engineering. Ultimately, it's like smarter ways to do specific arguments or to represent certain operations in ZK, or like better usage of parallelism, that sort of stuff. And that's where we've gotten, yeah, you know, there's still a lot of juice to squeeze from good engineering. And I find that like, yeah, it's pretty easy to reach for like a shiny new proving backend, but ultimately you can still do a lot with like clever engineering. And oftentimes, like when a paper first gets implemented, like the engineering and implementation isn't quite up to scrap. And so a lot of these new proving protocols aren't necessarily fast off the bat.
How much weight do you give to performance moving forward in your roadmap? I mean, is this like the core thing you're trying to improve, or are there like other features?
To be honest, no. I mean, performance is always important, but it's always downstream of like user experience, like how easy the library is to use, how easy it is for our developers to use it. And I think a lot of folks have found value in the library for a bunch of smaller models and computational graphs. So, for example, some of the risk assessment stuff that I mentioned isn't all that complicated. Like, it's not like some giant LLM or anything. And to be honest, I haven't found like a really convincing use case for like ZKing like giant LLMs and then proving their execution and verifying their execution on chain. I think there's still, I mean, there's a, you know, there's a wide gamut from what you can do in Solidity now to LLMs, and there's a rich space to explore before that. And we're really focused on like small to medium models at the moment, and delivering value there. But ultimately, everything we do from like the core library to the back end to the bindings on top in iOS and Python. Like ultimately, we're just trying to make this as dead simple to use for people.
Okay, so user experience over performance, but trying to connect the use cases to the performance. Like, is there when you say you are focusing on this like mid-size models, what does it get you? Like, what, or asking it in another way, what are the limitations? What you cannot do today or in the foreseeable future with EZKL?
I guess currently we can't. You, unless you're extremely patient, it's going to be very hard to do large language models. Maybe you can do one character every 1 to 2 hours. Uh, so it would take forever to get responses from there. So I mean, that's most of it, to be honest. It's really at scale that this starts to slow down.
So I'm asking you as a founder, you see this like Gen AI boom all around you, and you are building technology which is very much relevant as a
Mm.
PET, right? As privacy, security, verifiability. Like you give some added value to this like Gen AI. How does it like feel for you, or for you it's just like keep building and eventually it will converge. Just trying to understand if there's any psychological aspect to walking at the cutting edge, but not being able to touch really kind of like the industry um, in that point.
Yeah, for sure. Well, we've had some collaborations with some of the larger AI labs. So we've written some papers with Microsoft Research and some folks at MIT. There's some interest clearly from like the more traditional AI space, or I hate to use the word traditional, but from the larger labs, basically. Um, and there's some interest in this technology as a way to like improve security and potentially user privacy, but also to improve the auditability of models. I think a big issue right now is like it's very hard to audit the performance that is claimed from some of these large labs. It's hard to prove that these models haven't been trained on, say, like the evaluation sets that they're being evaluated on. I think this is one of the biggest issues right now. Whenever you see a performance metric, it's very hard to determine if a large language model has inadvertently or intentionally, uh, been trained on some of the evals that are used to evaluate these models. But I don't know if that business is that big. Um, I guess, okay, how does it feel? I guess this isn't the first time that I've experienced this. When I was working on my PhD, I was working on like some of the precursors to the generative models that we see today. I was working on variational autoencoders, which later became diffusion models, which are used for, image generation and video generation now. And then right as these models started taking off, I switched to crypto. Um, so I've always, I just have terrible timing. Um, so how does it feel now? It's very exciting. I think there's a lot of hype surrounding these things, but there's always gold amongst the morass. And so the key is to like really keep delivering and just focus on what we do best ultimately. Because I think it's kind of interesting because the category that at the intersection of crypto and AI when we started was tiny. I mean, there was really us and maybe like one or two other projects. As as I'm sure you've noticed, there's a lot of hype and buzz around like the intersection of the two, though in a very different way and approach to what we're doing now. I think what a lot of folks are doing now is basically just connecting LLMs on chain with like no verification or anything, which I think is a huge security liability, and eventually something bad's going to happen. But not that I wish that, but I can sort of see it coming. Um,
Okay, so actually, let's touch this point for a second because I think it is important, and maybe you can expand a bit about the security concerns. What happens when you are not using verification properly with crypto and AI?
yeah, I mean, okay. I guess we can use the risk assessment example again, for a lending protocol. Um, I guess if you're someone using this protocol, you basically, and let's say, for example, the risk assessment model is not verified at all. So you have a server, you've given it, a wallet and a private key, and you've given it admin access to a contract, and you basically allow it to run and continuously update values on chain. And I guess if you're running this model off chain, it means that users basically need to trust that one, the claimed model matches what's actually being executed, that the developers haven't, rugged the protocol and swapped it out for something else, which they can exploit. Two, that the model hasn't been like tampered with in any way. Three, that the inputs to the model and the outputs to it haven't been also tampered. Um, yeah, and I guess in those conditions, like a sufficiently motivated attacker could basically deploy a compromise model that underperforms. They could manipulate the input data before it even reaches the model. It could execute adversarial attacks on the model, which most computational graphs are vulnerable to. Yeah, there's a whole host of like security vulnerabilities, and it basically broadens the window of attack for a lot of folks. And so I think especially with like in an on-chain environment where people are, errors are irreversible. Like the cost of like one of these things getting exploited is immense.
I see. So, what would you say what can you tell us about your go-to-market strategy? Meaning that, for example, based on what you just said, I can come up with the idea of let's have a team attacking different protocols that are deploying AI on chain. And then, you see that there are like many issues come to us. This is the proper way to do it. What's it like right now for EZKL? How do you bring users to use the library?
I think, well, I think currently our usage base, I guess our user base currently is like very aware that these are bad security practices. And in terms of projects that are running these other sorts of agents, I mean, I hate to say this, but like it's often indicative that the project uh, maybe isn't all that serious, I think, in some ways. And our users are, in some sense, a reflection of our project. And so we've aspired to like really work with people that have their users' best interests in mind, uh, to put it euphemistically. But in terms of like educating and expanding on these things, I think it's very easy to show like how easy it is to exploit these things. I think the canonical example is adversarial attacks. And if you the classic graphic is like there's an image of a panda, you flip one pixel and suddenly it classifies it as like a chair or a table or something, and people viscerally quickly understand that like these things can be vulnerable to input tampering. But I think ultimately, like a lot of the AI agent projects currently are capitalizing on the hype and aren't necessarily there to build for the long term, is the truth.
Right, right. Um, Staying on the topic, AI and generative AI, it is kind of like a big revolution. And I guess that at some point, even if today what you defined as traditional like ML is still like, I don't know, 90x percent of the market, at some point you would probably want to be relevant also for this like large language models, transformers, and yeah, there's going to be also a lot of money there. So are you thinking about it? Or like there are steps? Do you know what are the steps that are going to be required for you to make it part of the addressable market for you?
Yeah, for sure. I think this goes back to the performance discussion. I think ultimately right now, like we're in a position where we can generate revenue with some of the smaller models. We have money coming in. We can validate some of the hypothesis. And I think if we hit a certain revenue threshold, we can really invest in like developing a prover system that would scale well to LLMs, basically. And I think there's a clear path to that today, that we can deploy. But I think there's still so much. There's a lot of low hanging fruit on the lower end that we really want to explore before we like dedicate like 12 to 13 months to the development of a new proving system. Because yeah, I think people are very quick to jump the gun, and it's in some ways like if you come from an engineering background, I think it's a very reassuring thing to be like working on the proving system as opposed to like you have this thing built and people want it and you should go and sell it and like get people adopting it and using it, which is currently, you know, internally we've had those same biases, but currently we're really focused on like we have this core product, people like it, the user experience is pretty good, and we can improve it, and that's what we're going to focus on at the moment, more so than like proving LLMs currently. That's not to say that it's not in our future, but I think until we see like sustained demand at like the level we're at now, it's going to be a little bit deprioritized on the roadmap.
Can you break it down even further? Only if you can, like tell us some features that are in the works.
Yeah, for sure. I mean, as you mentioned earlier, we have the metal bindings that just came out. Currently, they only offer a 10% improvement. We can definitely get that much better to make like client-side proving even more of a reality than it is today. Um, in terms of like, I mean, currently we're undergoing a security audit as well. So trying to make the library as secure as possible for end users. So really, I mean, that is something we really want to focus on is like making sure the library is as solid as possible if people are going to use it in production, which they are this quarter. And so we need to make sure that things are extra well done.
So I want to share that recently we hired an engineer that was working in an academic institute on using on EZKL. So I know that you have that many academics actually prefer and use the library. I wonder what it's like. I mean, what are the is this something that just like get in your way, or like do you encourage it? Is it like another type of use case for you?
No, I mean, ultimately, yeah, Jason and I are academics. We love it's sort of a love-hate relationship with the academia. I honestly, the fact that researchers are using it is awesome. A lot of our earliest users were PhD students or master students that wanted to try out the library. I think it's a very appealing tool for them because they come from a machine learning background and don't necessarily know about ZK snarks, but they have some research idea that they want to explore. And the library makes that super easy for them. Like they don't necessarily need too much ZK knowledge to be able to do research, which is awesome. I think we've learned a ton from those projects, typically because academics tend to be like somewhat ambitious in terms of what they want to do. And it's also a relatively low stakes environment for us to try new things and to sort of push the envelope with them, which is super fun. And on top of that, they tend to be like relatively forgiving users. They're used to using like somewhat cutting edge, kind of clunky tools for research. And so honestly, yeah, our collaborations there have been super fruitful for the development of the library.
Okay, I want to go back to the point we discussed about the Halo 2 prover, which is for sure not legacy. And I know that your own version of Halo 2 is optimized in many different and amazing ways. But still, there is a very good level of innovation that's happening in the industry around ZK technologies. What is your strategy? I mean, do you think that at some point you will integrate or move into a completely new prover? Like, what's going to be how are you approaching this problem? Not missing out.
Yeah, I guess it's always a question for us. I guess what I said earlier is that ultimately our priority is reliability and security. Ultimately, this is like ultimately any ZK library or product is at its core a security product. You're making this claim that this thing is somewhat infallible and robust. Halo 2 has been around for a while. It's been deployed in production. It's had a lot of eyeballs on it to ascertain that this thing is pretty solid. I think there is always a risk of rushing new proving systems as products to the market. I mean, even this week, there were a bunch of exploits discovered in Plunky 3, and some of the projects that use Plunky 3, like SP1, those sorts of things. There's always a risk that, like, if you rush these things to market, you're going to introduce vulnerabilities that are going to negatively impact your users, which is definitely not a position that we want to be in. But that's not to say that we shouldn't think about like how to improve the proving backend or to swap it out once like one of the shiny or new proving systems, is sufficiently tested and like has enough eyeballs on it to claim to be robust. Um, and I think the way we've architected the library makes it in such a way that it would be some lift, but not too much to replace the backend. A lot of these proving systems still use Plonkish arithmetization, which is what Halo 2 uses, and it would be the way we've constructed it currently would mean that we could basically swap out the backend at a moment's notice.
So you have some kind of a modular design, and I guess that you are also structured internally to absorb such a change, meaning that you have some cryptographers that are looking into new ideas and ways to integrate them or to switch and such, right?
Yeah, correct. I guess these are some of the improvements that I can't quite discuss yet, but we'll be announcing them, I think, at ETH Denver.
Right. So Dante, you have a very rich ecosystem. Can you or do you want to highlight a few of the or some of the partnerships that you've made over the years and how they contributed to you or how you contributed to them?
Yeah, for sure. Well, I guess I touched on, our relationship with academics and how they've sort of like helped us push the envelope on the library. Um, I think, obviously the DeFi applications and stuff have been very good, but I guess, a lot of the decentralized inference and decentralized AI networks kind of use us as a core component of their stack, as a way, basically, if you use one of these networks, you want to guarantee that the model that you requested to run actually ran. And I think one of the projects that we're closest to and that has been most fruitful has been Inference Labs. So they operate on the BitTensor network, and in particular, they've been live for quite a few months, and it's been really interesting because the competition from nodes on their network has been so fierce, and the engineering has been so clever that it's also folded back into our library, and it's improved the performance of it, almost tenfold since it first started. And so I think they've really cracked like creating a good competitive environment and orchestrating and architecting good economic incentives to drive improvements to our core stack. And that's been honestly super cool to see because now we have this community and this ecosystem that we can lean on whenever we need performance improvements, say for a specific circuit or for specific parts of the stack. And having that leverage has proven to be invaluable.
Yeah, I have to say that Inference Labs are operating as part of BitTensor, and for sure, do not sleep on BitTensor. It's they, they they got some stuff right, and it looks really promising. As Dante just said, there is a very healthy competitive environment that boils down, in the case of that we discuss here, to improving prover performance, which is not something we have in other places, and that's great. Uh, Good. So this leads me to our last question, which we ask everyone that come on the show, and it is to name a project that you are bullish about.
Oh, damn. Well, I haven't had time to prepare this one, but I think as I was mentioning earlier, the project that really changed my opinion on ZK identity is Sundial, who is building the on-flow ZK protocol. Um, they're they ship exceedingly fast, and they're very good app developers, and they have a history of developing and delivering like excellent viral products. So watch this space for Sundial and on-flow for sure.
Awesome. So with that, I would like to thank you, Dante, for joining us and sharing your story and EZKL journey so far. Wish you good luck and hope to catch up soon. And yeah, for those interested to learn more, we've added some links in the show notes. Thank you. Thank you again.
Thank you. Thanks for having me. Bye bye.